Hi guys, we are trying to solve the next task, and the next task would be the following. So it calls the minimum insertion to balance a parenthesis string. So let's check the task. We are given a parenthesis string contains only characters with open and closing parentheses. So the parenthesis string is balanced if any left parenthesis must have a corresponding two consecutive right parentheses. Left parentheses must go before the corresponding two consecutive right parentheses. In other words, we treat open as an opening parenthesis as, and this one as the closing parenthesis. So for example, this one is balanced, this one is balanced, this one is balanced, and this one is balanced. Yeah, so we see that for any open parentheses, we should follow two closing one. So you can insert the characters at any position of the string to balance if needed. You can insert the characters and at any position of the string to balance it if needed. Return minimum number of insertion needed to make balance. All right. So let's check. So we have some input. So in our case, input is a string with open and closing parentheses. So our string length, I believe, can it be empty? No, so at least one characters we can have. All right, so a maximum 2 in 5th power. And yeah, and string only contains this one. All right. So let's check. So if we have an open parenthesis, then output would be 2 because we need a closing one. If we have open and closing, output would be 1. If we have something like this, output would be 0. If we have something like this, output should be 4. All right, so let's think about solutions. So the first solution, I'm looking for a stack. So what does it mean? So I'm going, so for example, I have this string, input string, and I have my stack. So when I see an open parenthesis, when I see open one, I need to put it on the stack. So I put, then I see closing one. When I see closing one, I should take an open from the stack. So when open, put in the stack, when closing, take from the stack, when closing, yeah, but I can have something like this, and in this case it should be 2. Yeah, because I need open parentheses in this case, and I think this one is the most this is the most complicated, because if I see closing parentheses, I need to check if my stack is empty. Yeah, and here is interesting. So let's think about how can we do this. Okay. So stack empty. Okay, so when stack empty, then yeah, I need to check how many, like, do I have another closing parenthesis? Yeah. Then I check a next string. So let's say that then I go in not to the end of the string, but yeah, I'm going to here, I'm going right here. And trying to take these two elements. Okay. Yeah, so when stack is empty, check next string element. So when closing, I need to check next string element. And here, if open, yeah, so I check if open, tag is empty. Yeah, because like here, so I put, then I see closing one, I check next one. So if it's closing one, yeah, I always pull out from the stack. So yeah, when stack is not empty, then I get this out from the stack and check the next element. If it's open one, I just put it. Yeah, I would just check this next one. If it's closing one, yeah, I would just jump by one in my iteration. Yeah, and go to this one. Okay, so logic will be the following. So I'm going to the stack. I'm put element, then when I'm here, when I'm here, so it's closing one, I check if my stack is not empty, I pull this out. If it's empty, then I increment by one because I need an open. And then I check the next element. And if the next element is also closing one, then I just jump here. If it's open one, I put into the stack and also jump. Yeah, and also jump by one. All right. So the time complexity here would be linear, and space complexity would be also linear. I believe that this can be also probably done without space, just some integers, but yeah, let's implement it simpler. So I have a stack, characters, then I iterate over my chars. Yeah, I need to jump, so I need iteration of this index. Okay, also I have my results. I return this. Here in the loop, I check. I also going not to the end, but like this. If char cs char at I, so if c is equal to open, then stack at c. Else, if stack is empty, else, so if stack is empty, then I increment my result by 1. If not, stack pop push. Alright. So here, then I check the next char. So is char at +1. Here I'm checking if my next is equal also to is not equal, yeah, is equal to the end. Yeah, I will just skip. If it's equal to start, I would, yeah, because if it's closing one, then I should just skip. If it's open one, then I will stack at stack at open parenthesis, and also I need to increment my result, and here I would always here I need to jump by 1, so I plus equal to 2, because I'm jumping here. And at the end, I can have situation when my stack is not empty. So stack size is more than 0, then result. So if stack size is more than 0, it means that for each open parenthesis, I need to bring 2 closing 1. So multiply by 2 or just 0. Well, let's run. Okay. So let's take this as an example and we'll check how it works. So at the beginning, I have an empty stack. Then I have every time my character. So I put my open character, again put my open character. Then when I see closing one and stack is not empty. I take character from here. Yes. And my current C is closing one. And I check if I check if, and the result is 0. So it's not, so it's not an open one, because this one is closed. It's also closing one. So yeah, I'm just going by I plus 2. So currently I is equal to 2, and okay, let me think. And yeah, maybe it should do like this. Yeah. It's closing one. Yeah, I check result. Stack is empty. Take it from the stack. Next element. Yeah, here I need to check if I is equal to my last element. Here is else. Yeah. So here my I is equal to last element, and it's open one. So I need to check. So if stack so I'm open, and if needed, and here I'm just add result plus plus, because I'm on the closer one and it's last element. Yeah, and that's it. Check. Yeah, let me check one more time. All right, so for 0 I put, for 1 I put, for 2, so currently I'm on the 2, I'm go here, stack is not empty, so I take out from the stack. I is not the last one, so I take the next element. Next element is the same, so I'm adding 2, so it will be 4. 0, 1, 2, 3, 4. So currently I'm here. Yeah, so here I'm check. Okay, C is closing one. I'm going here. Stack is not empty, so I take out from the stack. And here I check. Okay, so I is my last element. Yeah, so currently I is equal to 4. So I increment my result by 1. And yeah, then I is 5. And yeah, so I have 5 elements. So I'm going here. So my stack size is not greater than 0. So here would be result 1. Interesting why it's like this. Let's check. So stack and also results. Why I have this one? Yeah, let's print stack here and also I think here so I put then 2 then 2 0 0 1 2 0 1 2 3 4. Yeah, I think it should be like this. Yeah, because I was adding like 2 and then it adding another 1, so it was like adding 3 in total. But yeah, let's check. Yeah, I think that it's looks not really nice. Can we implement it better? So for example, when I have 1, I would when I have an open, I have also like integer count, and open will be like 2, right? So I need to closing, then and again 2, then I have closing, so I decrement by 1 3 and 2. Here it works, but when I have closing one, yeah, so when I have closing one, I have my count equal to 0, so something like this. Then network trial. Okay, network error. Is it works now? What is a network error? Okay, output limit exceeded. Yeah, that's our output. Let's remove it. And let's try it once again. Yeah, so it's accepted. Thank you very much. I think with count it will also work. So for example, when we see open, it will increase our counter by 2. But when we see closing one and counter like 1, if it's less than 2, if it's less than 2, yeah, because for example it can be something like this. Then we have 2, then 1, right? Then 1, yeah, then correct. But if we have 0 and now we have closing 1, if we have 0 and now we closing 1, then we can make something like -1. Or like 1, and then we have another closing 1. Yeah, so here should be 1. It's interesting. How can we do with closing 1? Yeah, I think that for open 1 we just increment our count, and when we see closing 1 we have to check the next 2 elements. So we can get like this or like this, like 2 options. When we see like this, we just we have to check our count. So count, in this case, when it's 1, can it be 1? Yeah, it can be 1. So in this case, +1. Yeah, let's do another time. Thank you.